Hey there, students, and welcome to this explainer. If you've been staring at Chapter 4 of your food chemistry textbook, just kind of wondering how on earth you're going to memorize all these pathways, classifications, and deficiencies before exam day, well, take a deep breath. You are in exactly the right place. I'm going to walk you through this material step by step to help you structure your notes perfectly and really lock this stuff in.
Here is our game plan for mastering this crucial material today. 1. Meet the inorganic builders. 2. Roles of essential minerals. 3. Vitamins, the organic essentials. 4. Water versus fat soluble. 5. Dangers of nutrient deficiency. And finally, 6. Next steps for students. Let's jump right in.
Section 1. Meet the inorganic builders. Defining minerals.
So what are we actually talking about here? The absolutely crucial point for your notes is that word inorganic. In chemistry, when we say inorganic in this context, we mean these are elements outside of your typical carbon, hydrogen, oxygen, and nitrogen compounds. They are fundamental, raw chemical elements from the earth. Think of things like sodium chloride, literally the table salt in your daily diet. Your body desperately needs these raw elements to function properly, but how exactly does it categorize them?
Well, your textbook brilliantly categorizes minerals into two distinct families, and it's based entirely on the quantities your body demands. It's a really elegant split. Macro minerals on one side, trace minerals on the other. So it all just comes down to volume.
To lock this into your memory for the exam, you need to contrast the macro minerals directly against the trace minerals. Macro minerals include things like calcium, phosphorus, magnesium, sodium, potassium, and chlorine. These are the heavy hitters. Trace minerals, on the other hand, are the little guys needed in tiny amounts, things like fluorine, iron, copper, zinc, and iodine. But, what exactly defines macro versus trace in strict numerical terms?
Okay, grab your highlighters, because here are the magic numbers for your flashcards. The defining threshold you absolutely must memorize for macro minerals is 100 milligrams per day. If your body needs an amount greater than 100 milligrams daily, boom, it's a macro mineral. Conversely, trace minerals require an amount less than 20 milligrams a day. That is a massive difference in dietary requirement, but don't let those tiny amounts fool you. Trace minerals are just as essential for your survival.
Section 2. Roles of essential minerals. What do they do?
Broadly speaking, you can think of minerals as your body's construction workers and project managers. They build incredibly hard structures like your bones and teeth. They regulate your energy transmission and make sure your muscle contractions actually, work. Beyond that, they play an essential functional role by activating enzymes and controlling the pH of your body fluids, which maintains their electrical neutrality. It's literally keeping your internal battery balanced.
Now, for your specific study notes, you need to match the mineral directly to its physiological target. I guarantee you this is exam material. Match calcium to the structural formation of bones, teeth, and the composition of secreted milk. Match iodine directly to the thyroid hormones. Without it, your thyroid basically stalls out. And match iron to the hemoglobin in your blood, which is exactly what allows your red blood cells to carry oxygen around your body.
Let's flip the script. Section 3. Vitamins, the organic essentials.
Unlike those rock-solid minerals, vitamins are organic compounds. But the absolute key takeaway here, the one thing you must remember, is that your body cannot synthesize them. Because you can't make them internally, they absolutely must be obtained through your diet. Even though you only need them in very small amounts, a lack of vitamins will severely reduce your growth rate and cause some very specific, very nasty deficiency diseases.
Because of that, the textbook builds a completely different classification tree for vitamins. We aren't dividing them by the quantity you need like we did with the minerals. Instead, we're dividing them by their solubility. Basically, how do they dissolve?
Which brings us to Section 4, Water versus Fat Soluble, the vital contrast.
Let's break down the terminology really quickly. Hydro means water, so hydrosoluble vitamins are those that dissolve in water. There are 9 of these in total. Lipo means fat, or lipids, so liposoluble vitamins dissolve in fats. This group is exclusive. It encompasses just 4 specific vitamins denoted by the letters A, D, E, and K. Now, the consequence of this solubility is super fascinating. Because hydrosoluble vitamins dissolve in water, any excess quantity gets rapidly eliminated from your body through urine or sweat. This means they are highly unlikely to be toxic unless you're taking massive, unnatural doses. Liposoluble vitamins, however, are a different story. They can't be flushed out in urine. Instead, they get stored up in your fat tissues, and because they accumulate like a battery, they're much more likely to become toxic if you consume them in excess. As a general rule of thumb, you'll find your water-soluble vitamins in fruits and vegetables, while your fat-soluble vitamins are hiding out in fatty foods like butter and liver.
Just to be perfectly thorough for your flashcards, let's rattle off those 9 hydrosoluble vitamins. You have vitamin C, and then you have the 8 members of the B-complex group. That lineup includes thiamine, B1, riboflavin, B2, niacin, B3, pyridoxine, B6, folate or folic acid, vitamin B12, biotin, and pantothenic acid. Knowing these names will absolutely save you when it comes to those tricky multiple-choice questions.
So, what happens if we mess this up? Section 5. Dangers of nutrient deficiency.
Your textbook specifically throws up massive red flags about 2 major medical problems caused by severe deficiencies. First is osteoporosis, which you can visualize as a fragile, porous bone matrix. The second is anemia, which is a dangerous drop in hemoglobin levels.
To keep things perfectly organized in your mind, map the disease directly to the missing nutrients. Osteoporosis is that dangerous loss of bone mass that leads to fractures. It stems from a deficiency in vitamin A, vitamin D, or the macro mineral calcium. Anemia, on the other hand, is a problem caused by low hemoglobin levels in the blood, and this is triggered by a deficiency in iron or vitamin K.
But hey, the good news the textbooks highlights is that you can actively avoid this kind of devastating bone mass loss through your everyday lifestyle. You can eat things rich in these nutrients like butter, milk, and liver. Or, and this is pretty amazing, you can help your body secure vitamin D literally just by stepping outside and getting enough exposure to sunlight.
All right, time for action. Section 6. Next steps for students.
As your textbook instructor points out, you've got some homework to do to really lock this in. You have unsolved exercises waiting for you on page 71. Try those first. Then flip over to page 74, where the solved exercises are, to check your work and understand any mistakes. Finally, when you feel totally confident, tackle the model test on page 84 to simulate the real exam experience.
I'm going to leave you with a final challenge to test your true understanding today. As you close out this explainer and hit those textbook exercises, ask yourself this. Looking at your dinner plate tonight, will you be able to identify which exact organic vitamins or inorganic macro and trace minerals are sitting right there fueling your study session? If you can look at a glass of milk and immediately think calcium, macromineral, over 100 milligrams, bone structure, well, you are ready for this exam. Happy studying, and I'll catch you in the next explainer.